Hi, everyone. Good morning. Welcome to join our session. I'm Jimbo from Microsoft vscode-java team. This is Mika from Red Hat Eclipse Tools team. Today, we are happy to announce support Java C in JDT language server. So here is today's agenda for our session. At first, I will give an introduction about the existing JDT ecosystem, and also we will share the user issues we have faced in the JDT language server. And after that, Mika will talk about the solutions we have tried to solve these challenges, and also we will talk about the technical details, how to enable Java C in JDT component. Next, I will give another demo to showcase how the experience looks like if you enable Java C in JDT language server. And we will also give some further plans for our Java C project. So here is the terms when we're talking about the JDT ecosystem. In the middle of the diagram is the JDT core. That is originally developed by the Eclipse IDE. JDT core is the Java development tools. In the underlying, it uses the ECJ as the Java compiler and also as the underlying Java parser. So ECJ is the Eclipse compiler for Java. On the right side of the diagram, this is the old JDT-based ecosystem. That is the Eclipse IDE, which integrates the JDT by default to provide the Java language support for Eclipse IDE. So on the left side, this is a new ecosystem based on the JDT toolchain that is based on the language server protocol implementation. So we have a JDT-LS, which is a language server protocol for Java based on the JDT toolchain. At the moment, vscode-java is the most popular one to adopt the JDT language server to provide the Java language support for VS Code. vscode-java released its first version in 2016, so it has been 9 years past. So we have got millions of Java developers daily using the using VS for their Java daily work. So we also receive some feedback from them. So here is one of the top issues we have faced from the user side. The first one is about the out-of-box experience in the IDE tuning toolchain. So what users expect is a strong consistency with their local build tools when they open their Java project in Eclipse IDE or vscode-java. But in reality, we observe some discrepancies in the JDT-based tuning and the local build tools because the JDT-based tunings use the ECJ as the compiler, but the build tools by default use the Java C. So these two compilers have different behavior in some scenarios. So this brings a challenge for us to find some way to mitigate the gaps between the IDE tunings and the build tools. The second top issue is about the support of new Java features. Nowadays, the JDK is evolving faster than before. So for every 6 months, there's a new JDK is released. So it brings challenge to for our Java language tuning developers. That means we have to iterate fast as well. So that brings a question. We need to find a reliable way to catch up new Java feature support in the language tuning side. So this is the problems we have faced. Next, I'm going to hand over the sharing to Mika. He will talk about the solution that we have tried.
Thank you, Jimbo. So to provide to those users what they need, we will need to probably change things in JDT. Before going into the details of our proposals, let's showcase quickly the architecture of JDT currently. On the left of these diagrams, you see the typical feature users expect for an IDE for code analysis. So there is problem reports, the binding for control click, the code completion, code select. You have the research, and for Java world, you also have the compilation. Those are the features expected by users to get usable IDE. And each of those features currently in JDT directly uses the ECJ API for parsing, for resolving, and for code generation. So those features do rely on the Eclipse compiler for Java. Thank you. Sorry. So this Eclipse compiler for Java has some advantages for sure. The first one is that it does perform well. It integrates very well in the Eclipse IDE because it's been developed together. So there are some good APIs that do fit well the Eclipse IDE. There are some very nice features in the ECJ that are missing in Javac, such as the proceed on error flags that allows to create class files with syntax errors in them, which are convenient for debugging. There are some static analysis, such as the resource clause, the use variables, that code. All that is specific to ECJ, and those are good features. But there are some drawbacks about ECJ, which when we are to improve it, ECJ, like any compiler, is a difficult code, a lot of difficult code to maintain, so it requires a good skill set, which is not so common. One particularity of JDT is that the parser uses JAX-PG, which is also a tricky technology to use, which is not so hype, so it's hard to find documentation to use it well. So that adds to the difficulty. The maintainer community is rather small, especially for the difficulty of the project. It's really very few people who can help efficiently. And of course, because it's a different implementation, it can happen that ECJ doesn't behave like Javac will behave. It doesn't mean that it's wrong or right, it's just different, and users don't get the difference between different and wrong, so they assume that Javac is always right and ECJ is always wrong. That's sad, but that's how things are. So there are those advantages and pitfalls in ECJ. We try to improve ECJ, to contribute things to ECJ. When I say we, it's my team at Red Hat, together with some people from Microsoft. We tried a few things. The first one was to find ways to improve the parser, to contribute to the parser. Maybe there are some design refactoring that we could offer to make it more efficient and more efficient to maintain. Clearly, we didn't find anything. Maybe there is nothing to be found, to be honest. So that was a dead end. We considered using more class from the JDK or third-party libraries, using symbol, using utils that are already existing anywhere else. But the impact on the code was rather low, so it was also a dead end, not so profitable. We considered replacing just the code generation that turned the code into class file by Javac1. But this is not sufficient enough because at dev time, when you're in your IDE, you don't have the class files. Actually, you're using the DOM from the source file. So you don't need the code at that stage, the class at that stage. So it was not so useful for an IDE story. And we also tried replacing the parser with Javac1 and keeping everything else from JDT, but the coupling with the parser and the resolver and the build was too strong to allow replacing one element. So after all those attempts, those failed attempts, we considered to just replace fully ECJ by Javac in JDT. And let's discuss that proposal. Why we choose Javac? It may seem obvious, but it may be worth reminding. It's the reference implementation. It's at the core of the ecosystem. It's where Java development happens. It's used as the default compiler by all tools in the supply chain, Maven, Gradle, Jenkins, everywhere. It's what everyone is using, so it's standard. It's less surprising. It's fully working out of the box. It echoes the next step. It's fully working also with new Java releases because Javac is part of OpenJDK. Javac is up to date with the Java specification always, which is pretty convenient. And this is also because the maintainer community is bigger. There are more people working on Javac than people working on ECJ, so they can do more work faster. So to us, we are convinced that JDT will benefit from using Javac because users will get what they want, basically more consistency with Maven builds or Gradle builds, and also support for newer Java faster. And as maintainers, we believe that using Javac in JDT will make JDT more capable of shipping support for new Java release earlier because it's already provided by the compiler. It will make JDT integrate better in the bigger Java ecosystem, so JDT will get closer from OpenJDK project. It will be more involved in the Java specification than it is now. It's already a bit involved, but it could be even more involved. It could be more sustainable because Javac seems more sustainable. It will be surviving as long as Java is surviving. So as long as Java is there, Javac will be there. There is not much to worry about. So that's more reassuring for JDT. And it would allow JDT to focus more on the usability parts of JDT, the model, the code selection, all that, because there will be much less maintenance required for the compiler. So we do want to rely on JDT, at least for JDT-LS and vscode-java, for the stack that Jimbo mentioned earlier. That's not trivial. Let's discuss what we propose concretely. The proposal is to allow Javac to hook, Javac instead of ECG in JDT. We are happy that Eclipse is an extensible platform. Its API are well designed. It's easy to let to implement strategies, different strategies, and let the IDE choose which one we want. So we will try to hook Javac in place of ECG in JDT. So the first part of the proposal is, if we look at the features on the left, the IDE features, instead of directly hitting the ECG parser API or the ECG resolver API, those features will use the intermediary JDT model, which is already existing, for AST DOM unbinding. This is the org Eclipse JDT core DOM package. So instead of directly using the org Eclipse compiler batch package, it will use the org Eclipse JDT core DOM package. So we need to build these DOM objects and use them. And the code generation will still use the compiler interface as it's using now. So that will allow to decouple the IDE features from the ECG parser. And next, when we look at how we produce the bindings or how we will do code generation, instead of directly using implementation that use ECG, we create interfaces in between. One will be iCompilation unit resolver, and this interface could have multiple implementation, and JDT could pick one or the other. The default one would still be ECG, the one in JDT core currently, but we already have an implementation of this interface for Javac, which is in another bundle, and we can already build the DOM bindings and the AST using Javac. And the next is not a new interface, it's just using the compiler interface that's already existing in JDT, using Javac implementation to create the class files. We face some challenges in the development. This is non-trivial, of course. The Eclipse culture, which is very sane, mandates for minimal API change, backward compatibility, and so on. So when we introduce new interfaces and so on, we have to be very careful about the grain of the API, the extension, and so on. So we try to do our best here, and so far so good, I hope. One tricky thing is the minutiae in conversion. So what we do is that we have the Javac compiler model, and we want to translate it to JDT compiler model. That's fine. But there are a lot of small details where it's not exactly the same thing. You always tweak one thing here, there, and so on. It's difficult sometimes. The very good thing is that JDT has a very good test coverage. It has 70,000 tests, I believe. So the test coverage has really helped us to identify the parts where we need to improve our conversion and to identify issues before our users face them. And the next challenge is that Javac is very capable of IDE features, but it still is mostly sought for command line. So we have to deal with some performance and memory consumption issue, which are mostly fixed, but still could probably be better. I let Jimbo do the demo.
I will give another demo. Basically, there is 4 parts in my demo I will cover. The first one, I will use a real project to show how the Javac works with JDT language server. The second part is about to support the annotation processing support out of box with Javac. The third part is to incremental build with Javac. The last one is to show some behavior difference between the E3J and the Javac. So I'm going to switch to another demo. I'm going to use VS Code for the demo purpose. So here is a project that is open the Spring Pet Clinic in VS Code. At first, we have released the Javac support in language support for Java by Red Hat extension, the pre-release channel. So if you want to try, you need to install the latest pre-release version of the Red Hat Java extension. There's another configuration is about the settings. Important to use, integrate the Java C support, you have to configure the latest JDK as the tuning runtime. So there's two settings to configure. The first one is to configure the Java JDT-LS.java home. You have to point a latest JDK 23 as the tuning Java home. The second one is a setting to turn on Java C support in the language server. Now I have the setting set up. My workspace is now switched to Java C. So the most explicit evidence to tell that the workspace is hooked Java C is the preference view. If you open the vscode preference view, you can see the diagnostics. From the diagnostic style, you can tell the difference. So here is the Java C style diagnostics. The text edit, the diagnostic message is reported by Java C, and on the right side is the problem ID. So we just show the Java C code directly. You can see Java C uses the meaningful text to report the problem ID, something like the compiler.1.proper. So this is Java C style diagnostics. Here is a window that is hooked with ECJ-based JDT language server. If you take a look about the preference view, so the ECJ-based problem ID is just use a number to represent the error code. So if you can, from the problem view, to see Java C is enabled with the workspace. Next, I'm going to show the basic language features with Java C. The basic language feature like the basic navigation. So here is a Java file, so I can click the outline view to navigate the code. You can also use the go-to definition to show the definitions of a code. This is also served by the Java C parser. Now I'm trying to write in some code. You can see the code completion still work. And also there is a live validation is running in the back end. So this live check is also reported by Java C compiler. And we also enable the quick fix related with Java C problem ID. They just import the missing import. So this is the basic features. Next, I'm going to show the test runner or debugging still work with the Java C result. If you take a look about the target folder, so the all classes is generated by the Java C compiler. And we can open a test case. So the breaking point is hit. So in the variable view, it also still works. So this is the first part to showcase the basic language features works with Java C. So the next part is about the annotation processing support with Java C. I open another project. So I prepared some map struct-based annotation processing example. So I defined a user DTO. It defines two properties. Another entity is also defined two properties, but with different name. So I defined a user mapper. That we are using annotation processing to generate a map class between two different entities. So it will map email to mail entity. So let's go to check the generated source. So from the generated tag, you can see this is generated by Java C compiler. Let me make some change in the source code. I just rename the email to a new email and remap the two entities. Let's go to the generated source. You can see the Javac is just refreshed the generated source on the fly, so you can tell from the generate method. So this is annotation processing support. It still works with Javac. The next part I want to show is about the incremental build with Javac. You know, incremental build is a very useful feature in ECJ and the JDT tool chain. So we want to bring the similar capability to Javac. So here is a package folder. It has 4 classes. One is DTO record. Another one will reference the DTO. So there is a main reference the DTO factory. So this another one is observer. Let's go to the target folder. You can see in Javac, so for those classes without errors, it can generate the class files, but with errors, it cannot generate the class file. Now, I'm going to fix the compilation errors to see how it happens. So since this class is a reference on undefined constructor from the DTO, so I'm going to fix the constructor in this class and add the missing property. So I just saved the class. You can see the compilation error disappear from the DTO factory. Let's go to the disk files directory. You can see since the DTO factory, its compilation error is disappear. So you can see the class file is generated well. If you take a look about the timestamp of the class file, you can see only these 3 class file is refreshed upon my modification because they are affected by my change. For the observer class, it has no relationship with my change. So you can see it's not touched. This is how incremental build works when we switch to Javac. So the last scenario I want to show is about some compilation behavior difference between ECJ and Javac. So in this net window, this is the ECJ-based JDT language server. You can see it has some use case. It can report some errors. The first one is about the character support in the package folder names. So in ECJ, it's strictly required your packaging name must follow the physical folder structure. So for this case, I just used a name as a folder name, such as in folder.name. So the ECJ will report some errors that the package name does not match. This is the first case in ECJ. The second case is about the generic type inference for some cases. So ECJ will report some kind of type inference error, like this type mismatch. So this snippet is copied from GitHub issues from JDT core repository. So this is the second case about the generic type inference. The third one is about the annotation processing support. So for some case, if your annotation processing is involved with some inner class, so ECJ will report some kind of error, like abort compilation error. Let's go to the Javac-based workspace. For the first use case, if your folder name has dot characters, so Javac can recognize it well, so it has no errors. If you go go to the class target classified directory, you can see it can generate the class where. For the second case about the same case for type inference, so Javac has no errors here. The third one, you can see Javac can also handle the annotation processing case well. So that's all case I want to show today. So we believe enable Javac is an alternative choice for users to opt in. So if they want to have the consistent behavior as their local build tools, so they can try to Javac. That's my demo. I'm going to hand over the sharing to Mikhail. Okay, is the approach you want to try out Javac in other IDE or editor. The first one is about the Eclipse IDE. So we upload the Javac P2 in this link. So if you want to try it, you can download it from this link. The second one is about how to try it in VS Code. So I have demoed the steps. The third one is if you want to try it in other editors with JDT-LS. So here is the approach. You can also download the Javac artifact from the link and enable it. I'm going to hand over.
Okay. So when it comes to the code, so this slide won't spend too much time on it. It's more for people who are used to going deep into JDT. The main entry point for the code, if you're interested, first it's on GitHub, on the Eclipse JDT-LS organization. The first part is the Javac compiler, which implements the JDT compiler interface using Javac to generate the class file. That's easy. I mentioned earlier an I-compilation unit resolver interface. This one has a Javac compiler unit resolver implementation, which allows to turn the DOM from the Javac AST into a JDT DOM. 3 classes are involved, one to convert the DOM, one to convert the problems and the diagnostics, and another to convert the bindings, which are the links between the symbols. This code does not depend on JDT, on any change in JDT. It's available and ready for use, more or less. The other bit about JDT using DOM instead of ECJ in most features, there is one part which is in compilation unit class, where we, instead of parsing the class to reconcile the model, the reconciler, we have some hooks to use JDT I compilation in each resolver instead. The other one is code select, and this one has been merged, I believe, in JDT, where instead of using the parser, you would use the DOM as well. The code complete is under development. We still have work to do before it's sufficiently usable. The index, populating the index using the DOM, it's done. And one part that is still under development is the match. So when you get an index hit, you still have to verify whether this result from index is a real match or not. And we are still working on completing this part. So that's the code, coarse grain. One note about this code is that it's way easier code than what you would do if you were to contribute to a compiler. It's integration code. It's only data mapping, data translation. It's integration level, which is, in my opinion, more accessible than compiler level code. One note about release engineering, if you're to try those things yourself, is that to build against the new version of Java, in Tycho, you may need to enable Javac as compiler because ECJ may miss support for the new version of Java. If you want to build for Java 24 right now, ECJ cannot do that. If you enable Javac in Tycho, you can have your plugins targeting Java 24. That's just one line, and then it uses your toolchain and so on. I would even recommend, if you want to move forward faster than ECJ does, to enable it on your project. It's not too harmful. Now, the promise is, let's say Java adds a new feature in the language, a new construct, a magic switch, whatever. Before our proposal, and even now with ECJ, the four first steps listed here are mandatory, which means that before being able to use it in the IDE, you have to tweak the grammar, regenerate the parser, customize the parser, implement the analysis, the codegen, and so on. So those were mandatory steps and are still mandatory steps with ECJ as backend. With Javac, those you can skip. You don't need those to make progress in adopting a new Java feature. So to adopt a new Java feature, what you will do is only to map the new Java compiler elements to the mapping JDT core DOM elements. You just have to map things. That can involve that in some cases you have to define new model elements, new problem IDs in JDT. That is still necessary, but you don't need the compiler to do that. And then you have to implement the various conversion of the DOM, the symbols, the problems, and so on. So it's way less work, and it's only integration work. It's not so much compiler work. It's yours.
Yeah. So I'm going to show the next steps when we're looking ahead about this project. So in the current progress, we have reached our first MVP and give a preview release in vscode-java. So we were going to keep improve the quality and to make it more stable. At the same time, we are considered to combine with third-party analyze, such as find bugs with Javac in JDT language server. And also, we are going to make it as the default compiler in vscode-java in the future. So the last one is about to contribute our Javac work back to upstream JDT core to benefit more users. Regarding the contribution back to JDT core, so some handle work, some work is already integrated into the JDT core. The first one, such as interface for alternative compiler backend, this is already integrated in JDT core. There's some other work is still working in progress in the downstream Javac, such as use the DOM-based Javac parser to support more cases like the reconcile, hot completion, and the match locator. And also contribute the all Javac related work, we put it in a fork of the JDT core. So there's a Javac bundle. It includes the model conversion between the Javac model and the JDT model, and also the Javac compiler implementation. So we also consider to contribute back to JDT core. So this is our next steps. So we are looking forward to your feedback and welcome to have a try and give us your comments. This is the fork repo link. So you feel free to leave comments there. Thank you. That's all our sharing. Any questions?
You showed this from the viewpoint of the VS Code users and the language server integration. Is this now the official end of ECJ? And how do the JDT developers think about it?
It's not the end of ECJ because we never contributed to ECJ. So the fact that we are not contributing to ECJ anymore doesn't change anything for ECJ. So we are not reducing the amount of manpower for ECJ. It's not hurting ECJ. Now, ECJ, as long as there are people to maintain it, it will be there. There is no reason that this would directly hurt ECJ. But as an alternative, it may capture some interest away from ECJ through this Javac approach. So I don't want to say it's the end of ECJ, but it may just shamble the game, and maybe ECJ can be less maintained than it is because of it. But really, if ECJ remains alive for 15 years, that's all good. We do not need ECJ to end to support new Java version, basically. And to the other part of the question about how JDT developer, what do they think about it? We don't know for sure. We know that some people welcome the idea, and getting feedback from those people is part of the reasons why we're giving these talks.
First of all, congratulations. I looked at the problem you're solving and I ran away screaming a couple of years ago.
Yeah, thank you.
Second, the question is, at the time, a lot of this, the resolving, etc., depended tightly on the Eclipse project model. Is that still the case, or could you run all this outside of Eclipse code now? Like Eclipse IDE, right? Yeah.
So we do still use a lot the Java JDT project model, the resource model. So this work doesn't make sense out of the Eclipse platform and JDT project. I'm not sure I got your question, but
well, the question is, if you have Maven or something, it brings its own project model, right? And then you always have to do the translation synchronization.
Yeah, we do not translate project model. Translating project model is the role of M2E and so on. Here we are really on compiler level only, which is the hardest part in our opinion, in our expertise at least. We are not touching the project model yet. I don't know, maybe one day, but so far it's not where the pressure is.
Thanks.
Thanks for the talk. I would like to see benchmarks for performance and memory consumption. And did you talk to the JDK developers if they would make the internal interfaces public?
So for the benchmark, we don't have them. I can tell you that 2 weeks ago we were in a non-usable performance state, and because we knew we had the talk, we have prioritized performance, and at regular usage we don't see any usability issue because of performance. So it doesn't mean it's better, but the performance is not a blocker for actual usage in the current state. It could for sure be better. Whenever we want to improve performance, we can find cases. That's not an issue, but it's not a blocker anymore. And the interaction with the OpenJDK people, we have got in touch with them a few times for various reasons, and we are very happy of the relation we have with them. We have reported some issues because their internal code was not behaving as best for our needs. They have fixed it in about 2 weeks, just nicely without asking anything. So they seem to welcome the idea. They know of our intention, and so far so good. And we may want to contribute further to OpenJDK later. For example, the proceed on error flag, which is very important in an IDE where you have an error in your code, but still you get a class file that can be hot swapped, so you can debug code with errors. That is missing in Javac. And we want to provide it before we go to vscode-java, making Javac default. It's a must-have for production. And OpenJDK is a project like any open source project. If you come with resources and will to do things, they are welcoming. If you just ask them to do things for you, not so nicely, they are less welcoming. So as long as we contribute, they'll be happy, I guess.
Thank you.
The internal refactorings that you did in JDT Core, do they have any impact on regular JDT Core users, like replacing like using the DOM in between rather than the existing compiler APIs? And second question, what is the distinguishing factor of the language support for Java by Red Hat compared to the language support for Java from Oracle?
Okay. The first one was about we aim at no usability difference when using the DOM instead of the legacy strategy. Our goal is to be on feature parity. We don't want that users see this change as any form of regression. In some cases, it's harder to get the exact same result, but we try to get good results anyway. So even when there are differences, we try to minimize them in terms of usage. So the goal is really that end users don't have to care about it. What is the difference between JDT-LS and NetBeans-LS? You mentioned Red Hat and Oracle. I will just get rid of the brands. It's really Eclipse JDT-LS versus NetBeans language server, and both are branded respectively by Red Hat and Oracle. The difference is the same between Eclipse and NetBeans. I would say that Eclipse JDT has a bigger ecosystem, has very nice workflow. The proceed on error ones and the incremental builds are awesome, and they are missing in NetBeans. So those are the features that we believe are worth capitalizing on JDT over using NetBeans language server. And NetBeans language server is, I think you tried it, Jimbo. No, you have feedback about?
Yeah. So why we wanted to still keep the JDT with Javac, not use NetBeans language server directly, because we believe the ecosystem based on the JDT is valuable. We know there's many tools. This is still based on the JDT, like the Spring Boot tools. So we believe we enable Javac in JDT. We can still make the existing ecosystem still works. They have no any additional effort to adopt Javac in their tool chain.
You're lucky because it's just before lunch, so we can have as many questions as you want. I don't know if you're lucky. If you want to leave, feel free. Don't.
Perfect. I can go all day. No, I'm just joking. Thank you for the presentation. We do have a very, very, very long, large set of plugins in our workspace. So when you said performance, well, it's usable. Kind of depends, because probably you tested with only 500 plugins or something like this. We do have almost 2,000. So my question is like, do you have some, I mean, you did some performance. Do you have some results that you want to publish in the future, or is it on the roadmap to publish them?
So I would like to publish results, but we don't have results to publish. It's
Okay.
really feeling-driven development so far. We've just make it usable. We don't have metrics. We would really enjoy if you want to try it on your 2000 plugin and provide feedback. Usually for performance, Javac performs well too. The main issue so far has been memory, because it tends to load the class path multiple times. And what we need is to deduplicate the dependencies all the time. That's where the major performance issue has been so far. In ECJ, it's kind of built in, where you have your dependency, one jar. This jar is shared across the projects. With Javac, we had to tweak it because the same jar was duplicated and loaded as many times as there are projects or files. So that's the kind of issues we deal with. But when it comes to CPU execution, I don't think Javac is that bad. But we will need metrics, and we will need some people who are interested in such metrics to lead the way if you're interested.
Okay, I'll buy it. So how would I go about that? Like, do you have a set of tests, or do you have a methodology to use to test?
If you're interested in contributing, I would say first join on the GitHub repository, ask your question there, so it serves as knowledge base. The tests we use are the JDT ones, the JDT core ones. We do run the whole JDT test suite with Javac enabled. That's our test case so far. But we can create more tests. We can create a huge test where we create thousands of projects and make it explode. And then yell at Eclipse infrastructure for not providing thousands of terabytes of RAM. We can do that.
Thank you.
So no more questions? Okay, thank you for joining our session.